Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there.
All right, hey everybody. I hope you've all had a nice weekend. Actually, it's been about a week since I last streamed, so I hope you all had a great week. And if you celebrate Thanksgiving, I hope that was good for you as well. Yeah, so basically, I kind of burnt myself out working on the tessellation tutorial video because I wanted to get it done by the end of the month, and so I kind of crammed like 2 weeks worth of work into 1 week, and also had to deal with like the Thanksgiving holiday and everything. But so that's why I kind of just took last week off from streaming just to kind of clear my mind. But yeah, I feel a lot well, I'm ready to get started again. So let's see. Today we'll work more on the Hlsl Shader in Unity. Yeah, it's the next tutorial that's going to come out on my channel, so we'll do some more research today. And right now, these two balls on the left are using my special Hlsl shader, or my custom one, and then these are the default Unity ones. They look a little different just because they're in different states, but let's see. But the cool thing about the custom one is we can also turn on this little toggle button, and it uses a custom lighting solution. So what's up with those blotches? Oh, well, they're also on this one. I must be the Ambient Occlusion. Let's see. Yeah, if we turn that off, it looks better. I guess to fix that, you would just have it just based on only depth. Yeah, so what I was kind of surprised is that in 2020.2 or 2021.2, they have normal maps affect the depth normal pass, which they used to not. And I think that's what's causing these kind of weird holes in the, or not holes, these weird like occlusion shadows. I don't know what you call them. But yeah, and the normal map is just kind of a test normal map, so I'm not going to worry about it too much. Anyway, so what I was working on last stream, which I think it's been a couple weeks, or last time we worked on this project, was I was trying to add debugging support. Oops, sorry, I don't know if my sound was clipping a bit there, but I'm trying to add a debug support to the shader. Let's see. And we were having issues because it was saying that like the input data structure wasn't fully initialized, and the problem was, well, it's kind of, so basically, oh, the indentation's weird here. So the problem was actually this variable wasn't initialized completely, and it's because this tangent to world was kind of undefined. And the reason for that was because when I was calling this apply the normal map, which is in this file, I had forgotten to mark this as an out keyword. So basically it wasn't storing the calculated values of this tangent to world matrix in the variable. So yeah, we can see when I turn that off, everything still looks fine until I go to the rendering debugger and then just try to turn on something. Oh, it's because yeah, I need to turn it off of custom lighting mode. Okay. Yeah, so now it's not on custom lighting mode, so it's running the debugger, and now it's saying that the input data is not completely initialized. And that's just only because I forgot to add this out keyword here. So the tangent to world matrix wasn't being set. So that's kind of annoying because you would think that it would maybe be a little bit more descriptive on that error, so it would kind of tell you specifically what's wrong, but yeah, it doesn't. The shader compiler it's really good at some things, but it's not so good at error detection apparently, or error handling, I guess. But anyway, so now basically all of the debug modes work for our custom shader. So we have the albedo, which is gray, but we can add a tint, and you can see it shows up. And then specular is black because we're working with a metallic workflow. So if I turn on the specular workflow, it turns white because the specular tint is white, so we can see. And then the alpha is white. I guess we can. I guess that doesn't affect it. Oh well, it is opaque anyway. So if I turned it to transparent blend. Okay, I thought I had this working. Let's see here. Okay, so alpha is actually set here in the surface input. Okay, so it's a color sample times the color tint. So that's why I'm kind of surprised that this color tint should affect it. Okay, let's turn off the debug mode. And then if I I'm changing the color, not the alpha. Okay. Yeah, sorry, brain fart there. Okay, so if I change the alpha, yeah, it starts to turn black. I think it would even work on opaque mode, even though the alpha doesn't do anything on opaque mode. But then smoothness, you can see ambient occlusion. This one, can't really test. I guess I could turn this. Yeah, so there we can see the occlusion is, I think, in the green channel of this texture. And then emission, I have it. Yes, there we go. Okay, and then this is normal and world space, which is pretty useful. And then there's also normal and tangent space, which basically just kind of shows the normal map. Okay, and this lighting complexity is kind of interesting. It shows you how many lights are affecting that specific pixel. So if I turned on, yeah, so these lights are all baked lights, so that's why it doesn't affect it. If I turn on the spotlight, you can see the spotlight is affecting the plane and then also our two custom lit spheres, but it's not affecting this sphere. But if I move it over, then it starts to be affected. And the metallic. So there we see. Pretty self-explanatory. And the sprite mask. This is something I need to look into. I think it's for 2D mode, which I'm not really dealing with. And there's a bunch more. Like you can see text chords for all your vertices, and then the vertex colors, tangents. That's kind of strange, this little artifact there. It's probably just because of the sphere. Okay, then these are vertex normal vectors, which is why this one's rotated, so it's an object space. And then this validation mode, I actually need to look into a little more, but I think what it does, is it kind of sees if, actually, I think it like checks to make sure if pixels are within this range, but I need to kind of check because everything is like dark. Is neutral gray, so I don't know. Like here, why is the plane red and then the spheres blue? Okay, let's see. Maybe I can find out online real quick. Okay, so Unity, render debugger, material validation. Is that what it's called? Material validation mode, and then yeah. Okay, yeah, so it's just checking to make sure things are out of range, it seems like. Not exactly the most descriptive. Okay, this is telling that it exists. Okay, so it's not the frame debugger. That's tells you kind of like the order that things are rendered, which is useful in its own way, but okay, so it doesn't seem like there's been any info about it, which, I mean, I guess I shouldn't be that surprised. Okay, so I don't want the frame debugger. Check this out. Okay, so this isn't gonna help much. We'll have to look at the code. I guess we can do it now. All right, so we have this. Okay, so calculate validation mode. So the albedo. Okay, well the metallic version's right here, and it seems like, yeah, it just checks the debug color about to clamp it between here. Okay, and then if it's in between, then it just this luminance. Okay, it's going to be fun tracking down that variable or that function. But I don't see this calculate validation for albedo either. Let's just try the current document. Okay, maybe it's in debugging common, hopefully. Okay. So yeah, again it does the albedo, and then if it's the luminance, okay, well actually, yeah, it takes the luminance value out of the albedo, which I guess is kind of just like the brightness. And then if it's greater than this, then it sets it to the threshold. Okay. And then if it's in between, then it... Okay, then it kind of does the same thing except with the saturation. Okay, so it's kind of interesting. So it seems like it just checks to see if certain values of the material are between like these minimum and maximums. Okay, well, that's kind of interesting. I don't really know. I guess there's some reason why people would use that. I'm not really a level designer, so. Anyway. Okay, and then we also have shadow cascades, which are pretty cool. It shows you the cascade level for different objects when you move the camera around, which can be pretty useful. And then you can do lighting with normal maps turned off, and then just lighting. It's a little different because this lighting with normal maps, you can turn on and off only specific types. So you can have like only global illumination, or just the main light, or only additional lights. And then only emission. And then you can combine everything together, obviously. And then you can also see reflections, and then reflections with smoothness. Okay, and then this last one lets you see a depth map and then shadow maps for different lights. And then you can turn off things like HDR, multi-sample anti-aliasing, post-processing, and wireframes, which is different than the old way that Unity used to do it. These wireframes are pretty nice, actually. And then there's another option to see overdraw, which apparently it's having a little bit of overdraw right there. Okay, and then you can see, you can highlight basically out of bounds values that are either not a number or infinitive, or you can find values that are outside of a specific range. So that's pretty cool. So anyway, there's a lot of options here. I thought it was pretty cool. Oh yeah, so I want to turn that off. Okay. So anyway, but the only problem is now when we turn on custom lighting, basically none of those options still work. So I want to kind of see if I can hook into it a little bit. I've been kind of debating about the best way I want to do it, because right now they just kind of display like there's you know, like they display as normal, which is kind of weird. I think what I want to do is at least have them just show like, I don't know, magenta or something to show that they don't support this at the very least. And then we could even like try to support some of these values. The thing is, there's a lot of options, so if we had to rewrite everything, it'd be kind of a pain. But the other option is, I also don't like a whole lot, because since we're doing custom lighting, we use like a different input structure, but the debugging mode relies on the default structure of Unity's, you know, PBR-based lighting. So we'd have to like, I don't really want to force the custom lighting algorithm to have to use those structures. So I think I might, like in this function, maybe if debugging is on, I might try to translate the custom structure into the default structures and see how well that works. There'll be a little bit of code duplication, because basically I'm going to have to pass these values in for the custom lighting. But I don't know, I think it might be okay. I guess we could also just use a macro, but I think a macro would get a little bit confusing with all these different defines. So let's see here. So basically when we call this calculate custom lighting, we should see if it's in debug mode, and if it is, then we need to handle that. Okay, so let's put debugging stuff here. And we can see in the, clean that up, in the URP lighting library. Okay, there it was. Okay, so if we go down to the PBR fragment function, which is right here. Yeah, so if debug display is on, then it calls this can override debug output color. And if we look in debugging 3D, we can, that function is right here. So yeah, if there's a certain mode, then it either like overrides the color, and if it just gets completely overridden, then it just returns it immediately. But also it can modify values in this input data and surface data structure. And that's kind of where the issue comes with the custom lighting, because if we can't just use this function because it like modifies this data, and we'd have to like retranslate it back to our custom structure, which I guess, I mean, it kind of does work, but okay, well, let's just try it out. The other thing I thought we could try to do is, well, here we have like all the different debug modes, so we could actually try to support them all. But yeah, that's just a lot to do. But yeah, it's possible as well. Okay, well, first off, let's just say if it's a debug mode that we can't handle, we'll just return magenta. So let's do float, or I guess Boolean. What do I want to call this? I guess override with debug. Okay, so we'll just take an in-out custom lighting data structure. And I think that's, and then we'll also have an out override color. All right, so for now we'll just return magenta, which isn't that red and blue, I think. And then we'll return true because we'll just always override. And then in our function here, if we are in the debug display mode, then we'll call this function, and if it returns true, then we'll just return the override color. Okay, so otherwise we'll assume that we can just follow the normal algorithm. Oh, and one thing I want to do, I guess, just to kind of make it more clear that we're using custom lighting, let's add a really simple Tune shader. So what we, excuse me. So what we would do is just kind of step the diffuse value using a smooth step function. Okay, so the range is first, right? So I don't know. The actual values here, not super important right now. We'll do the same with the specular. Let's make that a little tighter. Okay. Oh, that should be flip 4. Typo there. Okay, so now we have a really simple. Okay, there we go. For some reason it went in. Accept my input. So yeah, now we have a really simple tune shader. So how come the additional light isn't affected by it? It doesn't make much sense to me because everything just flows through here. Maybe the step is just too big. No. Huh. Okay, that doesn't make any difference. Oh, okay. Sorry, I'll be right back. I just somebody's at the door. Okay, sorry about that. But while I was gone, I think I did figure out what is wrong with the tune shader. I don't really, it's not that big a deal because I mean it is not a real thing, but I think the issue is that this, yeah, so we're not stepping the distance attenuation at all. We only, so the smooth distance attenuation gets multiplied into the color right here. So in order to fix that, what you would really want to do is multiply this to the diffuse and specular dot product instead of into the radiance. Okay, so let's see. So I guess we could just make a quick fix here and just do something like that. And then this also gets multiplied into the specular dot product there. And then okay, but yeah, the thing now is that yeah, the spotlight is going to need to be a lot more intense to show up. I didn't think it'd have to be that intense. Okay, well, it does kind of work. Yeah, usually the ramps are a little different for additional lights just because of that. I don't know. I don't really want to spend too much time on this because it's not that important. So I think I'll just leave it how it was. This isn't really a toon shader. But anyway, so now it's obvious that it's different than the standard one. Okay, so this is kind of interesting with the toon shader. The ambient occlusion still kind of affects the color, but yeah, I guess this is just more another showcase of why the toon shader needs to be handled differently. Anyway, at least now we can kind of tell it apart a little easier. Oh, the music just stopped on my offline. Oh, okay, well, I am dropping some frames. Sorry about that. Okay, but it seems that it's back to normal. Okay, well, whatever. Anyway, okay, so now what we need to do is try to actually get some... Oh, well, we actually never tested the magenta color. So now when I go into the rendering debugger, oh, right. It actually doesn't even deal with alpha, so it should just return a float 3. Which I guess is fine. The reason the PBR lighting has alpha is because of the the glass overlay mode, where alpha is increased when there's a lot of reflectivity. So I don't know. You might, if you're doing certain things, you might want to be able to modify the alpha with this, but okay. Okay, so yeah, so now it's magenta because I have it on albedo mode. No, it should still work with those vertex attributes because it's actually using just a replacement shader to do it. Yeah, basically anything else that just turns magenta. Okay, so now we can try to support some of those other modes. Okay. So let's see here. A couple things is this shader doesn't have a metallic or specular mode, so on either of those, the override color should just be magenta. So let's see. Which we can kind of see here, but okay, and then maybe, let's see. So we don't really do alpha, but maybe we should. So let's just change all this to also have alpha, so that because it'll work better with the work better with debug mode anyway. So I guess that means I need to add an alpha value here. That's not how you spell that. Okay, and then so should be float 4 now, and back to set this to 1. Okay, so let's just make sure I didn't forget anything. Oh. Also, yeah. Okay, yeah, that was kind of a bug because I just realized I didn't. Like, if we had a transparent material with custom lighting, it would ignore the alpha. Okay, so it works now. Okay, so what is next? All right, so I want to go here, and then I want it to return magenta only if it's in specular mode or metallic mode, because our custom lighting doesn't have either of those. Okay, so here, see if I can find the name of the. It's debug lighting mode. I think it's debug material mode. Okay, yeah. So we can do a switch. Actually, no, we won't need to switch. So if I don't know if it works, like in C# where you can fall through. Well, I guess let's try and see. Okay, so we don't support specular mode. Oh, I just realized, yeah, we don't even include. We need to make sure that we include the debugging file. Okay, I guess it's included in the lighting, so we're good. And metallic. Okay, so it's either of these. We'll return true, and also set the, we'll override to magenta. Otherwise, okay, well, I guess nothing. So if we get to the end, we'll just return false and then maybe modify some of the stuff. So now what we need to do is convert our custom lighting data structure into surface and input data structures from the default lighting algorithm so that we can pass them to the debug common or this. Yeah, this function. The other option is we could try to, you know, recreate each of the options, but there's so many. I don't think that would be a great idea. So we'll have input data and surface data. And then we'll call and then I guess the override color. Okay, so if it's overridden, we might do something. But for now, we'll just return the override color. Okay, and then at this point, we need this can't debug override output color is either done nothing or it's modified something in these structures, so we need to convert them back to this lighting data. Okay, so it's mostly not too big of a deal, but okay, so here we can do the surface input pretty easily. Okay, I guess I'll just keep the same name so that I don't have to. And now we can just rename it here. Okay. So again, we don't ever use specular or metallic. So we can just set them to 0 either way. Okay, and then the albedo is just the custom lighting albedo. Oops. Okay, so we don't have a normal vector and tangent space. Okay, so let's just add all the fields we need for debugging. And then I also need to wrap this function in that. All right. All right. So we need the. Okay, I don't know what that was about. Kind of want to, yeah, have that prefix on it. Okay, there's also no emission. Oh, I did have an emission. Alpha. Okay, and we don't have any clear coat, so that's fine. Let's go ahead and say that just anything that we don't set will just be set to 0. This will help future-proof it and also clean up the code a little bit. Okay, and then the input data is going to be a little bit more involved because we have to deal with all this stuff. Okay, now here I kind of don't want, because if I forget something, I want to be able to set it myself. Okay, so position we do have, normal we do have, view direction we have, shadow chord we have, do I? Yeah. Fog chord. Alright, and vertex lighting. Alright, and also fake GI. Okay, and we also have the screen space UV, except I call it something a little different because I don't know, I kind of want to follow the same naming scheme as the other positions, but okay. And then yeah, for in this version, although I guess we don't even have to do that at this point, because if we weren't in this version, then yeah, this debug wouldn't even be happening. So okay, so now we need this tangent to world matrix. Yeah, and then the clip space. Okay, and then this light map stuff, as well as all this about MIP maps. Okay, well I don't need to worry about these defines because we'll just pass on what's set. Okay, so float 3. I'll add the debug prefix in a second. And then all this UV stuff. Okay, I'm just gonna copy it so I'll know, because we won't use this macro. Okay, actually, yeah, it's float. The others are float 4, except MIP counts an unsigned integer. Okay. So I think we finally got everything that we need. Do a little busy work here to get everything hooked up. All right. Okay, so now we've extracted all the information that we need out of the custom lighting data and put it into a way that the debugging algorithm can handle. Okay, so now it outputs things, and then it can also modify the values in here, so we need to translate back the other way around. So position world space equals input world space. Okay, but yeah, we don't really need to worry about setting all these debug values backwards because we don't need them in the actual lighting algorithm. So it'll just be this stuff. And most of these things can't actually change. So we could kind of look around and see what we don't have to set. But I don't know. It doesn't really... I don't really care about performance for these debug tools, so... Okay, so that takes care of that, and now we need to do the surface values. But again, only the stuff that we actually care about, so that'd be albedo, smoothness, emission, occlusion, and alpha. Yeah, I thought I named it like this. So that needs to change. Okay, so this kind of messy function should let us use all the debug modes, but let's see how it works out. Okay. Oh. Oh yeah, that's wrong variable there. Float 3 to float 4. Oh yeah, the clip space position is a float 4. Undeclared emission. Oh. Oh yeah, this wasn't supposed to be a LARP. This was supposed to be a max. The override with debug values must return a value. Oh, this needs to return true then. Yeah, the override color is set right there. Okay, so I guess here we'll set return false, but I'll also just set override color to black. Okay, this is supposed to be capitalized. Output parameter. Input data not completely initialized. Okay, well the reason, well it could be this stuff. Implicit truncation. Oh, okay. Well, that's just because these UVs are just supposed to be a float too. But I think the actual reason, and again, this arrow is not that useful, is that in my forward lit pass we don't finish setting all the values here, because we have to set all these debug values. Oops. Okay. I think I'll just copy this. So I don't have to remember all these fields. Okay, so the normal tangent space we have already. We already have the tangent to world. We have the clip space position. Okay, so this I'm just going to set to 0 because we haven't dealt with the dynamic light maps yet. We have the static light maps. Okay, I guess I do need to do those else if. So if dynamic light map on, which is always false for now. And then if static light map is on, then we'll set this. Okay. I'm gonna go like that because otherwise I'll have to do else ifs. And because I'll have to make sure these values are set. Okay. UV. Okay, so textile size. I could just call those special variables I have. And then the MIP count, we have to call a specific function. And I pass the texture as an argument. Which in order to do that, you need to use a special macro because the texture argument's always different. Or is different depending on if you're using OpenGL or DirectX or whatever. So this would be color map and then sampler color map. Okay. Let's indent this. Make it slightly easier to read. Okay. So yeah, now albedo. Oh. Yeah. Let's see if it... Okay, so it does work. Specular should be magenta because, yeah, we don't support it. Alpha. Good. Smoothness. Okay, again, I can't really test it unless I change the texture, but that does work. Emission. Okay, world space normal. Tangent space normal. Okay, lighting complexity. Let's turn back on that other point light. Okay. Metallic is also pink because we don't have metallic. And sprite mask. I guess... Well, I don't know. I guess I'll leave it because I guess it's supported. I don't really know exactly what it does. Let's see. Okay, it's not even handled here except for this try get color invalid mode. which is past the debug color. Okay, so it must be in one of these other, maybe debug common. Okay, so actually, the sprite mask doesn't do anything, which kind of makes sense because these aren't sprites. It just returns red. Okay, and then yeah, these all work. Okay, I guess we could do. Yeah, so again, this just checks to make sure the luminance is in between those two values. Okay, so this is the one that's going to be most interesting. Okay, it does work. It just took a little bit for it to show up. Lighting without normal maps. It's kind of interesting that the normal map affects the tune so much, but oh, maybe that's just because ambient occlusion's not in. I'm not sure. Okay, I don't. Yeah, so this kind of stuff's definitely not working, actually. It kind of works, but this looks cool. Is this rendering debugger in a Unity 2020.1? Yeah, that's true, Rocky Felix. I'm using the new rendering debugger. Yeah, it's only in 2020.1. And it lets you inspect a whole bunch of different stuff about your shaders. I'm trying to get it, I'm trying to support it in my, I guess, custom lighting algorithm that I'm using. But we can see here, something is a little weird because this is supposed to be global illumination only, but it's still getting the main light, so something is wrong. I don't think it even, yeah, it just doesn't change, right? Yeah, it's always the same, so I think the reflections work, but the smoothness is not the same between materials. Let's set them equal. Oh wait, yeah, this reflections, it doesn't take smoothness into account, so it must just, oh, I think it's actually because in the custom shader, the smooth or reflections only around the rim. So, because I have like a rim light effect to them, so that's probably why those look different. Okay, so yeah, we need to figure out this drop down because it's pretty useful. Okay, I just want to make sure these should all work because they're not related. And these are like just a screen space shader. Okay, so yeah, just this lighting is a little weird. At least this part does work. It takes away the normal map. Alright, so let's see if we can figure out how Unity does this in their default one. So, okay. Oh yeah, so this is where they just kind of change things, but okay, so the issue is they're, excuse me, messing with the specular and metallic modes, which we don't use. So So how can I... You've been tempted to up your project from 2020 to 2020.1. The experimental clause makes me nervous though. Lighting's looking awesome. Oh, well, thanks, Rocky Felix. Yeah, I understand for sure. I have liked, like, I usually stick with 2020.3 as well, but I wanted to add in, there's a whole lot of new features in 2021.2, so I wanted to make sure I support them. I mean, I do like it, and it's relatively stable, but I don't know. I'd maybe wait for the long-term support version before, like, committing. It's usually a safer idea. Unless you, like, really need something that's only in 2021. But anyway, let's see. So is that really... Where does the... I don't see the mask, though. So this is lighting without normal maps, lighting with normal maps. Okay, and so the reflections mode... Okay, so the only difference here is that it sets metallic to 1, or specular to 1, and albedo to 0, but it actually seems to work well with the shader, so... I guess because the reflections aren't affected by albedo. But it's a little... I mean, yeah, that does make some assumptions. Yeah, of course. Wait, I did see a change there. Okay, well, there's no reflections from the main light. Okay, I feel like, yeah, this kind of stuff has to be in the actual... Okay, why is this different? Yeah, the actual, like, algorithm, because I feel like they're excluding actual lights. Okay, let's see. Like, I bet this get additional light, excuse me, get additional lights count returns 0 maybe. Oh, used to that was in here, but it looks like they've moved it somewhere else. Okay, so there's real-time lights, HLSL, maybe that's where it is. Oh yeah, so this layer mask is new. Clustered lighting. Okay, well, here's the light loop. Okay. Oh, this is that special lighting mode where, like, only it's kind of like I guess this only uses lights that are close to the object, so you can have more total lights, but I think that's what that is. Anyway, don't really need that right now. Okay. Oh, I see. So if you only return the shadow coordinate, It adds in this, but if you return the world space position, or if you send it the world space and shadow mask, then also can maybe apply shadow masks, and then it can sample the light cookie. So that's kind of cool that it's like already supported. I didn't know if I'd have to add more stuff. Okay. Ambient occlusion factor. Okay, so this does ambient occlusion. Oh, I see. So you actually pass this input data. I don't really like that because that makes you have to use this input structure. But really the only difference is we have this. Wait, sorry, I'm kind of like getting ahead of myself. I'm looking for how it does the debug, but I don't see any mentions for the debug data, because I thought that maybe when you set that lighting mask that it would just like not return light data for specific things. But I guess if that was the case, then it would work with my custom shader as well. Okay. So I need to find out where it turns off the main light when you select this. Okay, this is all getting pretty deep in there. Okay, that's interesting. They do this before. I guess it doesn't really matter. I think in my custom lighting, I calculate the global illumination and then mix, but yeah, the mixing. Oh, okay, no, I don't. Never mind. Another data structure. What's in there? Doesn't look like it's. Oh, here it is. So global illumination. Oh, okay, so this must be where it does it, because it's global illumination color, main light color, additional light color, vertex light color, and then emission. So maybe check. Calculate final color. Thanks for the follow, Rocky Felix. I appreciate it. Okay, so this calculate final color must be where it's. Okay, so it also applies to the fog. Okay, so that's interesting. Do I not? Okay, so it does. Alright, so in old versions, it didn't apply the fog, so you had to call it yourself. But I wonder if in new versions it does. That would be the default lighting. Let's check the standard lit shader. Get rid of some of that stuff. Okay, so here. Oh no, it does mix fog. Okay. Alright, well then what's the fog here? So if fog fragment or does anything, then oh, it's like adjusting the fog factor. Okay, well, that's fine. Calculate lighting color. Oh, but it does mix the fog. So why do we mix fog twice? Oh, that was a symbol at forward pass. Nope, it still does it. Is that a bug? Because it does the final color here. Mixing the fog. Calculate final color. Then it returns it. And then it just mixes the fog again. That's gotta be a bug. Let's check. Alright, so I guess first of all, I'll turn off the double fog in my shader and see if it actually looks different. Like if it still applies fog. Okay, so turn on fog. I think we'll only be able to see it. Camera. All right. Okay, so it still does work for me. Trying to see. Okay. Well, I mean, it doesn't seem to be like incorrect though for the other version. Maybe it's not multiplicative somehow. Well, I don't know. But anyway, I'm not gonna... I'll just leave this out because... Yeah, you don't need this because it's already included. And with it turned off, it still works fine. Oh, but I guess we do need this for... if it's less than the Unity version because they only started mixing fog in 2021. So if it's less than 2021.2, then we'll still mix fog. Okay. Oh yeah, so what was I... Oh, I was trying to see about the lighting filters. Okay, so we're done with that. So it must be in this calculate lighting color. Oh, is that... Let's see here. Okay, so the reason it mixes fog afterwards is because it doesn't call the complete version, but... Wait, why does it still work? Okay. Oh wait, yeah, so here it only calls the argument with 2 parameters, right? Yeah, PBR. So calculate final color. This one needs 4 parameters. I don't think this is ever used. Okay, but how... Okay, now I'm really confused because it worked even when I did not mix fog, right? Oh, is this still on? I think it's still in custom lighting. Okay, yeah, that was kind of silly of me. Let's see, so turn off custom lighting. Okay, so yeah, so now it's not mixing the fog. Okay, so never mind. This does need to always be on. Oops. Okay. Anyway, that little tangent. Keep getting sidetracked. Okay, so I want to see this calculate lighting color, which is right here. So is only AOL lighting feature disabled or enabled. I'm not sure where that is, but okay, so now we kind of know. Okay, it's kind of funny. Yeah, it was this yeah, it has this albedo argument, but it always just passes one, I guess. Okay, so all right, so that's it can pass a different albedo value, I guess. I wonder where this is used. Anyway. So I wonder. Kind of weird that they use an if statement for this when they could just use like a preprocessor directive, because now every fragment has to go through 6 if statements. I guess it doesn't really. In shaders, if statements kind of have a bad rap because they're like they can be slow, but in this case it's probably not. But anyway. Now where in the world would this be defined? Guess I can check real-time lights. Maybe it's in here. I don't see it. Okay. Oh, okay. So the reason, yeah, it doesn't actually generate an if statement because if this debug display is turned off, this basically, the compiler will see this always returns true, and so it'll just remove the if block. But yeah, this is what I wanted to see, so I can just call this is lighting feature enabled as well with the bit mask. I wonder, I don't know why they have this special function for this when they could have just done the same thing, but oops. In my eye. Okay. But anyway, I think we finally have the tools to handle this. I don't think I'm going to make a little structure that has all those different values. I don't know. I don't think that will be super useful. I think all I have to do is in the get main light is if the main light feature is enabled or is disabled, I can just set the distance attenuation to 0. So let's see if is lighting feature enabled. Okay, so I guess this is slightly different, but so if this is false, then we'll set the main light dot distance attenuation to 0. Okay, and then if global illumination is on, then we'll do this stuff. Okay, and then I guess we can do it like this. So float 3 color starts as black. Okay, I guess a cleaner way to do this is I can that. So if main light, then we'll add it to the color. And then if is lighting feature enabled, additional lights. And finally, vertex lights. I guess we have emission as well. And again, this might look weird to have all these if statements, but I think that, like I said, if the compiler will just remove them all because they always return true if the debug isn't on. So they're not actually adding if statements, which is nice because it does add unneeded complexity. Okay, so the only other thing I need to do is handle this special case, which I'm not exactly sure what it does, but basically, let's see. If this is enabled, then we just return immediately. Okay. I guess technically I think this might be incorrect actually because it's applying ambient occlusion. So I think what I should actually do is like up here. Something like that. Okay. Let's check this out. So global illumination. Oh, by the way, the global illumination doesn't match because I need to rebuild the light maps, but main light. Additional lights, nothing right now, so but if I turn on the spotlight, and again, it works a little strangely with the tune shader, but you can see it is on. Okay, and then there's no vertex lights. Turn on emission. And then ambient occlusion. Okay, so that doesn't work, but that doesn't seem to make any difference. Except here. Okay. So it's supposed to just return ambient occlusion, I guess? So should this go... Let's look. So yeah, it's just returning the global illumination color. Which it says is white plus ambient occlusion. Is that true? Okay. Let's see if we can get it. Okay, so I think the issue is in the global illumination we add, yeah, we multiply the albedo back into it, but this, if this is enabled, the albedo should be white. But so how come it's not set here? So I guess what I have to do is if okay, well, maybe we can just handle this. Well, okay, so we want to apply the screen space ambient occlusion actually, so this should go afterwards. Yeah, so I guess it should just go down here. So if at this point we'll just return the color. Okay, maybe just not worry about the alpha. And then if this is enabled, we'll just set the albedo to white. Oh. Because this global illumination is turned off. So this is a little hacky, but let's just see if it works. Okay, no, it's still getting color. Oh, from the vertex lights? So what I need to do is set the bake GI to also 1. Okay, and yeah, and then I can move this up here. Okay, there we go. So yeah, now it's basically just the ambient occlusion. I don't really know why they put it in this drop down, because if you select anything else, it doesn't really affect anything, but all right, so let's see. So this mode is just pure lighting. Seems to work. I mean, I don't, let's see. Why is it? Okay, so I guess the reason this is different is because when we set it to one of these options, it sets the smoothness to a standard value. All right, and then without normal maps. Okay, so then it made a difference. Seems that it's going to make stuff darker. I don't know exactly what is happening here. I guess it's saying if you unclick this, it doesn't take ambient occlusion into account. Maybe it sets it to 1 all the time. Which maybe this is messing it up. I don't know, it's maximum anyway, but... Oh, hi Thoughts Bubble, it's been a while. How are you doing? I'm doing pretty good. I'm just working on some debug features. Basically I'm trying to get my custom lighting to work with debugger from Unity 2021.2. And I think almost at the end here, but... Alright, so what would happen if we actually have something with ambient occlusion texture? Oh, it doesn't seem to make any difference. Oh, but I think that's because ambient occlusion... Yeah, right now this isn't taking textures into account at all. Okay. Doing alright, just a bit stressed with university work, I guess. Oh, that's true. Around this time is when I usually had to get ready for finals, so I can understand that. I hope it all goes well. Okay, what does... Okay, so it doesn't do anything here. I don't know, it's very subtle, but... Maybe, let's see, is it only screen space ambient occlusion? So if I turn it off, does it make it so that drop down doesn't do anything? Yes. Okay, so I think what's happening, it also seemed to make this a lot brighter. So I think what was happening is the screen space ambient occlusion was always affecting this when it should only do it with this turned on. Okay, so how do I... So maybe what I would do is do another is lighting feature enabled, but only oh, I forgot that. I'm just gonna hope that this is named like this. No problem, thought bubble. Inspected token. Oh, I'm missing parentheses. Okay, that did seem to work. So now if I turn that off, okay, that's all I had to do. Okay, this is a little different, but I don't know. I think the way I've done it is makes more sense. So this basically just turns off green space ambient occlusion. So I'm happy with it. Okay, and then yeah, the screen space ambient occlusion really makes a big difference, doesn't it? Okay, I think we finally supported everything. I guess I should run through this stuff. Yeah, we already know this is working. Okay, that's fine. Wireframes. Overdraw. Okay, we tested that. Where's the modes to see bitmaps? Because we support all that bitmap stuff, but I don't think it actually uses them ever. Okay, well at least we have it for when they add that. Yeah, because there's that stuff to see like bitmap levels. Yeah, I don't see them anywhere. Okay. How has Unity version 2021 been for you, actually? You still have your current project in 2019. Never bothered upgrading since a fair amount of people I know had some grievances with 2020. Well, to be honest, I still mostly work in 2020.3. I'm mostly just trying out some of the new features in 2021 on stream today. But so far it's been pretty stable. I guess the only thing I would say is that for some reason, whenever you make a change to a C# script, there's like a noticeable slowdown when coming from 2020, whenever it has to recompile. So I don't know what that's about, but people have been complaining about it on the forums and they say they're looking into it. So hopefully there's a good solution. But yeah, I don't know. Unless you really need a feature in a newer version, it's probably better not to upgrade at the moment. Although I've had pretty good luck with 2020. I know it was buggy at first, but it seems to be pretty stable for me now. What am I trying to do? I think I still have it. I have something turned on here, so yeah, I just want it to go back to normal. Okay, so I think we're all done with the debugging. Okay, so somebody actually asked me about trying to draw text, and I thought I saw a function that did it, so that way you could kind of print out values on a shader. Let's see. Okay, yeah, so we almost done with the stream, so maybe we can try to knock this out. I think it was in the URP debug library. Although it seems like they've changed it, so maybe it was in the core then. Yeah, they had the sample debug font. So where you can print out a number. Let's see if we can get it to work. So I guess you return the screen space coordinate and then a number, and it should print out something for you. Okay, let's just... Okay, so what would we do here? Let's print out the red value of the albedo, I guess. I guess we could just override the color. So color equals sample debug font color. So we need to get the screen space and pixel, which I think I can use something from space transforms. No. I mean, I guess we could just use, yeah, the screen space UV and then multiply by the screen size. But I thought there was like an actual function to get screen space position. Probably not going to be easy to find. Okay, well, let's look at, here's kind of a trick. If you can't find documentation, sometimes you can look at the shader graph, like screen space or shader graph node, and see if it has, oh, if I can type it, if it has documentation in that, because they've kind of documented the shader graph a little better. Okay, but unfortunately it does not have the function name. Okay, so I just have to go looking in the shader graph herself. No. Oh, it's editor. Okay, well I guess the shader graph is all in the editor, so. I was hoping it would have nodes. Oops, I didn't do that. Okay, well if all else fails, you can create a shader graph and then inspect the generated. Oh. You can make a built-in shader graph now? Interesting. I didn't know that they'd done that. Okay, so yeah, if we just put that into the base color, I guess I'll make it unlit just so it's simpler. And then we can view the generated shader. And if you look through here, you should see where it fills the screen position. Okay, compute screen position. So we can call this transform world. So the clip space and then projection params. Okay, well, this is kind of what I was going to do anyway. Because the projection params includes the screen size. Okay, so anyway, float 2 pixel or position, I guess screen space. Okay, we don't need to do that because we already have the clip space position. Okay, so hopefully that works. Okay, so we pass the screen space and then the number that we want to print. So I think I'll just do the albedo. Okay, let's see what that looks like. Oh, okay, so it doesn't exist. Okay, I'm just gonna look through the entire solution and hopefully we can find. Oh, well, here we have it right here. Okay, that was silly of me. So we already have the function. Okay, let's look and see if I can find where it's defined. Okay, this is all shader graph stuff, I think. Okay, some functions. Oh, okay, so it's just doing projection sign. Where is this? So this is in the shader graph. All right. Okay, well, let's just not worry about this for now. I guess I need to include the core debugging file. All right. Okay. I don't see anything. Oh, you know what? I think it only accepts an unsigned integer. So I need to do like Okay, I don't know why. Something like that. Okay. I'm gonna apply the ground just so we can see. I guess. Okay, well, this function is not giving us the screen's the size in pixels, so maybe that's the problem. So if I do projection, I think projection params has the screen size. Maybe not. Okay, no. Oh yeah, screen params is what I'm looking for. Oops. It's hard to keep all these variables straight. Still doesn't work. It'd be really nice if I could find where this is defined. So I'm going to keep on looking through. Just all uses of the function. Why is it? Like, this is in the shader graph, so I don't feel like it'd be used by non-shader graph stuff, but those are the only definitions of the functions of the function I can find. Okay, well, how can I test this? Let's just pass. Okay. I guess we'll set blue to 0. Okay, so this should. Oh, is the screen space? Okay, that's another thing that's not obvious. What is the? Maybe I'm missing some values. Okay, so the pixel cord is int 2 there, but okay, no, that was a float 2. Then why? Oh, maybe. Let's see. Okay, so the compute screen pose is giving me okay, you know what? I'm just gonna copy this because I don't know. Can't find where this is defined. Okay, so this is returning a float 4. So it. Okay, but the x, y, I guess is really all we care about. But it has to flip the y. Okay. I mean, that's fine. Okay. I was going to copy and paste it, but I'm just going to assume that's the function that we're actually using. Okay, so you can see it's down at the very bottom of the screen. There's this narrow strip of yellow. And that's because... Okay, now it's kind of frozen. Unity, are you frozen? There you go. And I think that's just because the green... Yeah, so yellow is red plus green. So green must be 1 here, but then it goes negative. So yeah, I guess I do have to flip it because of the projection parameters. All right. Oh, I forgot the semicolon. Okay, so now this works more like I thought because the green, I don't even know if you can see this on Twitch, but there's a narrow strip of red. I guess it's 1 pixel on the bottom. I don't know why there's no black pixel though on the side of the screen. Okay, you can see the red. But I would have thought, well, I guess it wouldn't be black, it would be green on this side because I thought that red would be 0. Okay, so does that mean that, okay, so this is already giving it in pixels, I guess. Okay, so maybe the issue was just that it was inverted. Oh yeah, you can see 56 right there. Okay. Okay, well that didn't work how I hoped it would. I thought it would like repeat. Okay, so I guess I just need to do my own. Make it repeat every 32 pixels or something. Okay. Sorry, I don't know why. Okay, so that works. Alright, so now we can see it's printing 56 because that's the color of the red channel of the albedo. Now, is that right? Okay, let's just put in 99 to see if the actual number matches. Okay, so it does. Just trying to think. I don't really think there's any. I mean, this is sometimes useful, but the problem is, let's see. So if I like varied it based on, I don't know, like the diffuse value, then it would kind of, it'd be strange because the number would change like as it goes over the sphere. So I think you would kind of get like it's like all the glyphs would be all mixed up, so you wouldn't actually be able to tell what's going on. I'm trying to figure out if there's an easy way I can show that. Let's just so uint test. I'm just gonna do a really simple dot product, so for diffuse lighting. And then we'll multiply it to range between 1 and 100. Oh, forgot the parentheses there. Yeah, so this is the problem with this is that the value isn't constant over a glyph. Okay, now it's like frozen again. So this is what I'm talking about with 2020.1 or 2021.2. Like I can't move the. Okay, there it goes again. But you can kind of. I mean, you can still kind of see what's going on, I guess. So yeah, I don't know how useful that is. Yeah, no, it would be kind of cool if you could like separate this. If you want to do something like this, probably be better to do it with a post-process effect, where you somehow write like this value just to a color, and then you have like a post-processor that looks at that value and then samples like every 32 pixels and prints out a number. Although you can kind of see what's going on here. But if you wanted to like really be able to clean this up, that would be how you would make sure that the glyphs all match. Are those numbers representing the color values that the shader causes? You notice you went farther away from the light, the numbers went to 0. Yeah, that's correct. This is the diffuse value ranging between 0 and 1. So the light, I guess this is in shadow on this side, so that's why it's 0. But then as I go upwards, you can see it starts to go to 100. Of course, yeah, the kind of jobbled up numbers is what I was talking about, and that's just because the diffuse value changes faster than like they don't match up nearby pixels because each one has like a different value. But somebody had asked about debugging textures or debugging shaders with like being able to print out values, and I think this is the closest you could get. Now I kind of want to make that post-processing shader I was talking about though. Let's see. So just add a little idea. So text debug display with post processing. Okay. All right. So at least, yeah, we got it to work. I guess I'll probably show it. I mean, people really wanted to see ways to debug shaders in the tutorial, so I guess we'll probably showcase this, but for now I'll just comment it out. Okay, so what else? Okay, so we can... I think the meta pass is done, isn't it? I guess this doesn't support custom lighting. So how would I guess so if custom lighting isn't enabled, then I would... Well, I basically wouldn't sample the... Well, I guess I would still need smoothness, but we don't use metallic. Okay, so I guess what I'll do... Oh wait, I already handle it here, so custom lighting. Okay. So the meta pass is done, I think. Let's look and check out the lit shaders meta pass. Yeah, that's so wrong. Okay, so it just calls this universal fragment, which I think I'll actually call meta fragment. So what's different? Okay, so it has this more editor visualization. Even in the meta pass though? Okay, clean this up. Okay, so where would this be? Some meta input. It's not very useful. Need to head out for now, but it was nice to check in for a bit. Hope you have a good day. Thanks, Soft Bubble. I hope you do too. And yeah, I'll see you later. Okay, so it has this visualization UV and then the light coordinate. But I'm not sure where this... Or I can see this visualization. Okay, well, since we're going to be working on the meta of paths, let's first generate some good lighting. Sorry if my stream stutters for a bit, because this does use my graphics card. Okay, so now that should match up. I think I'll turn that off. Okay. This is blank, but... okay, well... I thought that might be a really quick thing, but it turns out I need to do some research about that visualization. But I think I better end the stream here. Been streaming for about 2.5 hours, so pretty good. But thanks everybody for coming by. I appreciate it. Next stream we'll probably work on this some more, but I might have done some work off stream, so might be something a little bit more interesting, but we'll see. I'll put some links in the chat if you enjoyed the stream and you'd like to connect with me elsewhere. Specifically, I have a YouTube channel where I do a lot of game development tutorials, so check that out if it sounds interesting. Anyway, I'll be back on Wednesday at the same time. Actually, a little earlier. It'll be around, let's see, 2:30 US Eastern Time on Wednesday, and I hope to see you there. Have a great couple days, and bye-bye.